Now, today's session is on, now this particular session is for Python for machine learning and deep learning model. So basically Python is a programming language which is being extensively used for these application approaches for machine learning, deep learning, or artificial intelligence, also very extensively used. Basically there are two languages which are very popular these days for this machine learning and deep learning. They are the R and this Python programming language. And Python being a very general purpose language, it is more extensive along with more extensive libraries. It is very popular among the machine learning and deep learning application developers. So today the content of this session will be like brief means around already Anil sir might have, he will be covering about the machine learning and the deep learning basic concepts also he will be covering, but still I will be having only one or two lines of definitions of machine learning and deep learning with respect to your algorithms or with respect to Python. Okay, why Python for machine learning and deep learning? That will be another topic which we will be covering. Okay, why at all Python should be required? We should use Python for this machine learning or the deep learning model. And there are certain specific, very peculiar features of Python which makes it suitable for machine learning and deep learning. And then we will be also talking about some libraries in Python for machine learning and deep learning. These libraries are open source in nature and are being used for developing these kinds of models. Okay, then there is the working environment of Python for machine learning and or the deep learning. Okay, I know about these libraries, but how do I implement it? Where do I implement it? So I will be giving a brief demo of those working environment where you can write your Python or your machine learning models in a Python environment. Okay, and then I am also going to cover a small use case or the small examples. Basically, linear regression is one of the very popular machine learning approach, which is the simplest one, we must say it, that is utilized for the developing machine learning and deep machine learning models. So I have taken one example of wheat crop yield estimation. Let us say I have certain amount of parameters, like it can be a temperature, it can be a wind speed, it can be a soil moisture, it can be the we can say some parameters derived from the satellite, like the crop health. So based upon that, whether we can estimate the yield of the crop after pre-harvest yield, means before harvesting, can we estimate what is going to be the yield of this crop this year? So we have taken one case study for wheat here for the state of Uttarakhand. So for that, although we have used multiple models for it, but for this particular session, I have used linear regression as one of the methods for this crop yield estimation or the prediction, we can say. Okay, so I can share that code also along with some sample data also with you, so that you can also put a hands-on for these kinds of models. The sample code is also there. You can further enhance that code. So by the end of this session, you will be having this linear regression, a sample code as well as sample data set with you, so that you can put your hands also into it. Okay. Then I have the same example. We have tried to split into train and test also, splitting the data set to train and test. This is a very common phenomena, or we can say common process in the machine learning or the deep learning models, where we divide the data set into training set or the testing set. Training set means the data set which is used for creating the model. Let us say I have some X, Y, and Z parameters are there, and I have some one, you can say, prediction P, X, Y, Z, 3 parameters, and one P is the prediction. For this X, Y, Z, I have some hundreds of values. Same way for the prediction, I have some hundreds of values. What we will do, we will divide these hundreds values into, let us say, 30 by 70. That is, the 70 is used for the training purpose. So since I have X, Y, Z values, I have the prediction values also. So it will say, okay, this is X, this is Y, this is Z, and this is the prediction. Second value it will consider. It will read all those values, all 70 values, and based upon the learning, it will create one model. Once the model is created, then what you can do, you can put the remaining data set, the testing data set, you can just give X, Y, Z values to your model, and it will produce some output. That output you can check with your test, the prediction which is already available in the test data set, these two data sets. So your model output and your test output, these two are tested. Now if they are not good, then you further train your data set, and once the data sets are, once the model is well trained and you have satisfactory result, you move further for taking some unknown data sets and giving it to the model so that you have the reliability of that model. The testing is only to check the reliability of the model. Okay, so that is very important. We will try to see how we can easily implement it in Python. Only one line of code is required to divide your data set into train and test. And that is also, again, if you want 70-40, 70-30 or 60-40, whatever you want it, you can just change one parameter and it is done. Okay, so this we are going to do at the end of this session. If you see it here, machine learning or the deep learning, what do we mean by this machine learning and deep learning? The very basic concept from Pythonic point of view. If you say it, it is a set of algorithms basically that parses the data. It will read the data set, learn from it. Okay, what is there in the data set? That I told you, one example I gave you just before that, okay, that XYZ parameters and prediction. So it learns from the data, it parses it. It parsing means reading the data set. It parses the data, learn from it, and then it tries to see, okay, if XYZ are these values, then this is the prediction. If XYZ are these other values, then this is the prediction. So it is learning from it. Once it has learned from that data set, it apply what they have learned to make intelligent decisions. Now, once the model is created, then it can be used to make some intelligent decisions as well. Whereas now this was basic for the machine learning. Okay, so the very thing is parsing the data, learning from it, and then applying it for intelligent decision making. Okay, so this is the very core, the simplest language of, simplest definition of machine learning we can say. Now, if we talk about the deep learning is also, we can say, a small subset of big umbrella, that is AI, artificial intelligence. Okay, it is also gaining much popularity due to its supremacy in terms of accuracy when trained with huge amount of data set. Means if your data volume increases enormously, then you can go for your deep learning model. So they have a different trend. All these, both this, the depth of this machine learning and the deep learning methods will be talked about more during this course in the coming session. Okay, if you see it here in that figure also, if I say I will take some historical data set, training process is there, then models are created, then you give a new data to it, and then the results are obtained. Okay, prediction is done based upon those data sets. There are numerous examples for it. Like one example I gave you, crop yield estimation. I want to estimate before the harvest, I want to estimate how much yield will be there this year. Can we do it? Yes, machine learning is providing you those facilities which can be utilized for developing such models which will predict those the yield as well. Another thing, can I predict somewhere underground water using machine learning? Yes, that can also be done. There is another application where you can predict about the water table also, underground water table. How to predict that? So you have to develop some data sets for it, and you just have some historical data sets also. Existing water table data you have, and you have certain parameters also. So you develop models based upon those existing water table values and the parameters. When models is created, then you apply this model to some newer area. Okay, so that is another example. Some other example from space technology, if we say it, urban sprawl, let us say, that is whether how much the city is going to grow in around say 50 years, whether that can be applied. Yes, that can also be done through this machine learning or the deep learning models. Another example, let us say from space, let us take one example. I have to, suppose I have developed one drone, or we can say rover, we will say, because one rover is moving, so whether the rover is intelligent enough to detect the obstructions in between. Let us say one rover is moving on the surface of Mars, and in between, and once it is moving, whether it can predict or it can detect the hurdles which are coming in front of it and accordingly change its path. So that kind of model you should try. Okay, once that course is completed and you have learned some idea, you have it, and so and very interestingly, there are huge amount of data set which is available online. Okay, even the Chandrayaan or the moon data, that is also available on the internet domain. can discuss. I will just share some the exact URL from where you can download the Chandrayaan data also. Or let us say about the yield. Then yes, we can download the yield data also. From the historical yield data we can download. Government of India, they have made a very nice portal, that is data.gov.in. It contains immense amount of data. From there we can download n number of data sets, and that can be utilized for these kinds of models. Another example is there are some other data sets, like we can say climate data sets. Okay, these all are also available. One site I will be telling you, that ERA5. Okay, they give very a large number of this parametric values you can get from there as well. ERA5. Okay, so similarly ISRO Bhuvan, they also supply some kind of data set. They have the satellite data, you can download from there. You can process it and you can generate some out. So once I have the satellite data, from that I am extracting some information, and that information then I am making use for some application. Okay, so that is very important over here. It comes. So there are numerous sources and numerous applications areas where in the spatial domain also, where you can apply these machine learning algorithms, so the machine or deep learning algorithms. Okay, so these are some basic examples I have given to you. Now, if you say Python, why? Okay, we have understood what is your machine learning, what is your deep learning kind of thing, and let us say why then Python only for machine learning and deep learning models. So the very the example is the very first thing that comes to my mind, that is how to get it. You can get it freely. Whether I can get the source code? Yes, you can get the source code also to modify it. So it is free and open source in nature. What does it mean then? How does it will help me? It is community friendly. It ensures community friendly, means there are many people who are using it, and they are putting their contributions to these libraries. So they have using these open source libraries or the free libraries. They have also free and open source means you download it, use it, or you can modify it also, and then again you publish it, republish it with some updates also. So that kind of things are available to it, and it guarantees improvements in the long run also, because an entire community, open source community, or the people are sitting sitting over the web. They are there to provide improvements on top of these kinds of libraries. Okay, this is a very basic example. Exhaustive libraries for the Python again. Solutions for every existing problem. It ensures solution for every existing problem. Means it is it is not required that you should write the code from the scratch. Search, you just Google search and you will get a lot amount of code directly available over there. And sometimes they are available in the form of libraries also. We will see what are those libraries, or how you need. Suppose let us say I'm generating one like in the morning. In the previous session, Anil sir told about the K-mean classification or the maximum likelihood classification or this type of classification. Whether I need to write entire code for it? No, you need not to write code for it. A library is available. You just need to call that library, and you should be aware of what are the parameters required for that method. Let us say K-mean. What are the methods required? What are the parameters required for it? I will say I require number of iteration is one parameter. I require number of classes. I require number, or it can be we can say some mean or mode. These parameters you have to just apply to it, or there are some parameters which can be automatically generated also from the data itself. So you should be aware of all those things. So you should. Once you are aware of those, at the basics of those methods, let us say K-mean, then you can easily implement it using these libraries over here. Just you have to type my model.K-mean, and you have to, in the bracket, you have to give the parameters. It will do the other work. It will do for you. Okay. So smooth implementation and integration. It is accessible to people with varying skills level and adapt it. Anyone can use it and adapt to it. Again, this is one example. It is increased productivity by reducing the time to code and debug. Means it reduces the time to code and debug. Example, let us say, I want to do a linear regression. How to do it? I have created my model.linear regression and bracket. Your model is created. The entire code comes into picture, into your current code over there. So only this much you have to write, and the remaining part, these libraries will do by themselves, because they have been written in such a way that they can be directly implemented into it. And they are well tested also. If you want to change it, the source code is also available. You can change it, modify it, and then again use it for your purpose. Okay. It can be used for soft computing, natural language processing as well. So these all features are available in the Python. It also works seamlessly with C and C++ code modules. Suppose you are some experience in the C programming language or C++ language, then that also can be integrated directly into Python. And one thing I have just missed over here, this Python is not only a desktop based, you can run it on the web also. .py file is there, your program .py, and that can be executed on a browser also. Okay, over the web also you can execute this program. It is not like Java also we have the applet kind of things. So similarly in the Python that can be executed on the web environment as well. Both desktop as well as web. We will see that also. Some of the features with respect to machine learning and deep learning. Okay, it has a very simple learning curve. Within just 2 or 3 days you can learn something about Python. It is not like you will keep on struggling how to write a simple Python code. No, the learning curve is very simple here. Just like you are speaking the language, the same way you can write it and it will start coding. Okay, and you can start the coding also. We'll see an example also of it. Okay, it is a general purpose language, not defined, not specific to any particular domain. It is a general purpose language. It can be used for not only for the spatial domain, it can also be used for the marketing or any other business domain. This language can be utilized. Like R, I was telling to you, R is it is also a very extensive programming language, but it is more towards the statistical kind of statistical approach. So all the statistical methods or approaches, they are very well documented and implemented in that R programming language. But this here, it is a general purpose programming language. Some ready-made packages for machine learning. What are those packages? Matplotlib. I want to draw something. So we directly have one library called Matplotlib. I want to do array processing. Suppose I am talking about an image. Now image, what is image actually? Satellite image is nothing but a 2-dimensional array. X-axis and Y-axis, I have the pixels and I have the lines. So it is nothing but an array only, and all those values are there. And there are different packages which are representing those arrays in different forms, in the form of an image. This we can have. Now this NumPy is not only 2-dimensional array, it defines multi-dimensional array. Let us say my satellite image, hyperspectral satellite image, which have hundreds of bands. So what does that mean? Hundreds of bands means I have hundreds of images of 2 dimensions. So I have 3 dimensions. One is the rows and pixel, and the third dimension is the number of the band. The band number 1, it has pixel and line. Band number 2, it also has pixel and line. So I have multi-dimensional array. Okay, that is a hyperspectral image basically. So it had a very good support for handling those array processing also, NumPy. And there are many models have been written. They all are based upon this NumPy model only, NumPy library only. SciPy. Some algorithms I want to apply now. Okay, this algorithm, scikit-learn. This is again one more very important library which is extensively used for machine learning here. Okay, and TensorFlow, excellent support for deep learning. This is for machine learning. So similarly, I have the TensorFlow, deep learning models, interactive data analysis and model using IPython notebook here. Now it also has something called notebook. Wherein it can be used. This interfaces can be used as a calculator also. You just write your code, run it, directly it will run. You need not to write the entire code and then execute it. But it allows you write one line of code, execute it. Another line of code, then execute it. Or you can combine all those lines together and then execute it. So both the things are possible using this IPython notebook or some other interface as well. Industry standard language for AI and machine language. Okay, this particular it has become like that. Now these are some of the libraries for machine learning and the deep learning. The green ones, they are the data processing languages, data processing libraries only. Because whenever I am going for a machine learning, I need to prepare the data as well. Data preparation takes some time because your data, because we are having a multi-dimensional data set, and all the data set may not be in the same form. We can have some missing values. I can have a mixture of numerical values and category values. So these pre-process, before putting the data into a model, I need to pre-process it. So that pre-processing, the excellent support of pre-processing available in your Pandas or NumPy. You just Google it also, you will get it. A huge support is available for this NumPy and Matplotlib. Matplotlib for graph purpose. I want to do different kinds of graphs I want to draw. So these are the very, we can say, atoms of this data processing in Python. Like in a human being, or the smallest particle, we can say element, is an atom. So similarly, your NumPy and Matplotlib, are the atomic libraries. Okay, they have a huge capabilities inside it. Out of them, many new libraries have been created. Now, if you see it here, Panda, it also takes NumPy. Something in the background, it has a NumPy methods inbuilt into it. It has been a wrapping kind of thing has been prepared out of it. Similarly, the blue ones, the red, the green ones, I told data processing and analysis. Data pre-processing and analysis can be done on that one. Suppose, and this is blue one, they are the deep learning libraries. Okay, these libraries are like MaxNet. This is basically, I will be talking more onto this also. Keras, TensorFlow, PyTorch. These are some of the libraries which are extensively, they are being used for deep learning models. Similarly, for the machine learning, we have scikit-learn or the Spark MLlib or Theano. So these are the three which are very popular. There are many although, but these are a little bit popular programming languages or the libraries which are being used for your machine learning model. Scikit-learn, we have now for this particular session, I have chosen NumPy and your scikit-learn as a demonstration also. Okay, how to do that programming into it. So that we will see at the end of this session. The next half an hour, I will try to cover up these two things, examples also of these two things. This NumPy and scikit-learn. Okay, these two I will be taking, and let us see how we can develop something out of it. The other thing you have to try of your own, like Keras, MaxNet, TensorFlow, PyTorch. The more you get it, the more you will learn. Okay. Now, if you say the TensorFlow, what is earlier I was talking about the deep learning model. So let us talk something about the features of the deep learning model or the libraries. One is the TensorFlow. It handles the deep neural network. It is extensively used for that one. The natural language processing can also be used for it. Partial difference equation. Sometimes you have to generate some gradients kinds of thing, or in the equations also very typically very complex equations. They have the ready-made modules for those things. You need not to write the code from the scratch. Just call those methods and it is done. Abstraction capabilities, image, text, and the speech recognition can be very much accomplished using TensorFlow. Effortless collaboration of ideas and code. You can collaborate also using this TensorFlow. It is offered by the Google. It is fast, flexible, and scalable open source library. Okay, scalable means it can be extended further. Similarly, the other deep learning model, Keras, it is basically also for the neural layer. A little, we can say, your TensorFlow is a very high-end library which is being used for the deep learning model. It can handle high volume of data sets also. Whereas Keras, a medium level of data sets that is required, that can be used for it. Now, what are those things? Neural layers, activation and cost function, objectives here, batch normalization, dropouts. But dropout means we can talk about like if you are creating a neural network. So there are different layers into it. Suppose I want to drop some of the some of the intermediate layers. So that feature is there. Pooling is again there. Keep again taking it from the different sources. Now it also supports both convolutional as well as RNN. That is a recurrent neural network also exists along with the standard neural network in Keras. So it is very a medium level data set. It supports very well in that case. It is high level, and again you can say it is a high level API on top of TensorFlow 2. So it has been further enhanced, and at the bottom it has TensorFlow only. PyTorch, this is basically used by your Facebook also. It is for tensor computing with GPU. Suppose you want to do enhanced processing, huge amount of data set is there, and you want to increase the performance of those computing. So we can have normal processing unit. Apart from that, we can also have the GPUs also, graphical processing unit. So that support is provided by this PyTorch. Okay, easy to learn. It can integrate easily with the Python ecosystem. tensors, like you can just call it torch.tensor, directly you can call it. Again, neural network, it also for the auto grade. What is auto grade? Auto grade is automatic gradient calculation. So that's one of the feature that is available with this PyTorch library. Similarly, if we talk about the scikit-learn, this I will be talking more also. One example I will try to take. Classification, regression, clustering, dimensionality reduction, model selection, pre-processing, all these methods are directly available as a dot function with this scikit-learn library. Similarly, the pandas, which I told you, data preparation and the pre-processing. Okay, this was machine learning, and then reshaping. Suppose there are many times we need to prepare the data and shape it in such a form that it can be it is in coherency with the other data sets. They have the same shape and size. Then only we can put it into a model. So the reshaping of the data set, pivoting, merging and joining of the data set, excellent support for merging and joining, missing data handling. So that is again a very important point here, because that is also required. Missing data can create the problem. So in pandas, directly I may be having like drop function. The missing, some data is missing, you kindly drop it. So only dot drop method you write it and you will get it. You need not to search it separately. One example I had for that also, we will see it. Various indexing options such as hierarchical indexing, fancy indexings are available with this pandas. Indexing is basically used for which increases your search of the data, improves the searching of the data sets. So for that it is required. Data filtration options are also available into it. And Spark MyLib, this is Spark MLlib library. This is again from one very popular open source project is there by the name called Apache. Okay, so they have also developed one machine learning library by the name called Spark MLlib, and this is used for the regression. All this method: regression, clustering, optimization, dimension reduction, classification, basic statistics, feature extraction. They all are available with it. And this is Spark Lib. This is Spark MLlib. It enables easy scaling of your computations as well. If we talk about the Theano, again this is again one more library which also has a support for the GPUs also. Strong integration with the NumPy, ability to create custom C code for your mathematical operation. You can directly use your C codes also. If you are existing some codes you have written, that can be taken up in this Theano library also. It is a robust library for carrying out scientific calculation on a larger scale. Okay. Now, if we talk about the MaxNet, this is again mostly used for the neural network. This is again deep learning only. It is highly scalable and support quick model training, used to train and deploy deep learning new traits. It has portability. Portability means you can take your code to different platforms. So that excellent support is available for it. Scalability is also there. Now, the Amazon's AWS prefers MaxNet as its choice for the preferred deep learning framework in your Amazon's cloud. So this MaxNet they have preferred for the deep learning framework over there. NumPy, again, this is a data preparation. This is the same thing that I told you, pandas. So that has been created on top of this NumPy and Matplotlib only. One thing sometimes I have heard also, NumPy and Matplotlib. Suppose you have one proprietary, you know that there is one proprietary software by the name called MATLAB. So sometimes people also claim that all their tasks have been which they used to do in the MATLAB software. Now with the Python, if they are having NumPy and Matplotlib, all their requirements are being fulfilled using these two. So we can say that their MATLAB requirement is fulfilled using your open source library of NumPy and Matplotlib. Okay, so that is very much very extensive library. It means it has a good strength out of it also. Shape manipulation, sorting and selection capability, Fourier transformation, linear algebra and statistics operation, random simulation you can do, support for n-dimensional array that I told you earlier also. Now, what are the IDEs for doing the machine learning? Let us come to now practical things. Okay, let us see how to do these things now. We may be feeling eager, we should start it. So there are the two options for it. First of all, you just download one package called Anaconda, and it has one option called one package, another sub package for it that is called a Jupyter Notebook. So once you install it and execute it, so this kind of window will appear for you. Now it has not only Jupyter Python. This Anaconda is a big package, a bigger one. You can say bada saap hai. Okay, so that way it has many things into it in its stomach. What are those things? R also it has, and this is Jupyter Notebook is one small component here. And VS Code, there are many things inbuilt into Anaconda, but we are only concerned with one Python with the Python environment. So Jupyter Notebook is there, so that can be utilized for it. And we have to take this one, Jupyter Notebook and Anaconda and Jupyter Notebook. Once you install Anaconda, automatically it will come into your dashboard over here. Then from here you can launch it, directly click it here and it will launch it. Let us say I will take it once like this also. How to start it basically, if you see it in my computer here, Anaconda, type it here, then Anaconda Navigator. So it will start like this. It start like this, Anaconda, and then you can see it here. It will come up like this. Okay, so this bigger window comes into your screen. Now, if you see here, there are many options available for me for the Python. Now, suppose I want to do my machine learning with the Python. Now, I have created one separate environment for me, like called the Geo. These environments can be created. It is always better you create your own environment. There is one base environment also that is called the root environment. It has its own library, set of libraries, some default library sets are there. But you create your, suppose your project has a different set of versions of different libraries, different versions of different libraries. So for that, you create your own environment, and in your own environment, you try to install those libraries also. Now, once Geo is there, now suppose Jupyter Notebook is directly available for me here. You click launch and it will open it for you. Just it will take some time. We will see that also. So it comes like this. I will just increase the size here. It comes like this here, Jupyter, and then at the browser only, it will open in a browser. Now here, so many things are visible to you. So what you can do, you can create here new. You can create, let us create one new folder first of all, because I want to do some machine learning. So for that, I will create one folder. So once you created new folder, it has already created one new folder that is called untitled folder. It has not given any pop-up for you. That is all, remember it. You have to search it, untitled folder it has created. Just click it here and then you just rename it. Now rename it, I will say my ML trial, my ML practice, you will say, practice, okay, my machine learning practice. So one folder I have created here, okay, my machine learning practice. Just click on top of it. Your workspace is now my machine learning practice here. Now here, you can say Python 3. Again, you go to this new option over here. I'll increase it further here if you are not visible to you. New, and then Python 3. And then here, I can start writing my Python code here directly. The first Python code, I will write it here. Let us say something, I want to do some calculations. I want to, let us say 500 or 5432 into, let us say pi, the 3.14. Directly it will act as a calculator also for you. If you want some input from the user, directly I can say x equal to raw underscore input raw input. I will say here something, I want to ask something from the user now. Enter any number, okay. This one example, and we are not going to spend much time onto it. So if we say it here, this x is your variable now. It is directly created variable. No need of defining those variables. You say x equal to, it will create one variable and store that number into it. If I say now shift plus enter button you have to press to execute it, or here you can click on this run button also. I will say shift plus enter. It will ask me input only. Basically Python 3 is there, so it is only input. You click it here, enter any number. I will say the number is 5565. Now you can see that this number is, you can see, click enter over here. So if you see here, what is the value of x? Print x, bracket print x. Oh, sorry. Or shift enter. So it will say print x, the value of x is 565. So this way, you can start coding in your Python notebook also, Jupyter notebook, using the Anaconda and the Jupyter notebook. So directly you can start coding your things over here. Now let us say NumPy I want. NumPy is not there in my program here. So you need to install it. That NumPy you have to import into your Jupyter notebook. How to import that one? That also very simple over here. If you see it here in the Anaconda, it has one prompt also. Okay, Anaconda prompt. So you will say this Anaconda prompt. Click it here, it will open this thing. It is showing very small size, so I will increase it here. I will increase the font to 28, let us say. I think it is visible now. Properties, I will increase it further, 26. Color I will take, let us say this one. Screen text I will take black. Okay, so yeah, leave it. So I think it is visible now. Base, now here we have to write Conda, or you will say, I will cite Conda, the small command Conda, INSTAL, Conda install NUMPY. Press enter and it will install. It will import this NumPy into your Jupyter environment. If you see it here, it is the base environment it has taken. So we can change this environment also. ACTIVAT. Activate one geo environment we have created. We can create it. Now geo will come. Now all the libraries or the versions of library which you want, they will go into the geo environment. So here I will write Conda INSTA install, suppose say Keras. So it will install it directly over here. So already I have installed it, so I am not executing it over here. So this is one option of Jupyter notebook. We will come back to it. Let us say the other option, the easier one, no need of installation. Google has provided you something wherein you can use your codes without any worry and hurry about whether my libraries are there or not, or whether the updated library is there or not. Suppose you are not able to install some libraries into it. So already there, everything is available in your Google Colab. Most of the libraries are directly Google Collaboratory. So from therein you can also start your programming, your Python programming for machine learning over there also. How to do that one? You require one Google Gmail account is required for that. So let us say if I click it here, I will say it here, just close it here, then I will say here, if you increase the size, okay, now just type it here, Google Colab, okay, just type it here, then it will show you the first, it is there, research.google.com. This is your first, this is the cloud platform which has been provided to write your Python program. So welcome to Collaboratory, click it here, it will open the entire library for you over here. Okay. Now, once this page is opened, now here you can create new notebook also. It has options for the Google Drive. Suppose your data set is there, you want to do something on that data set. So you can keep your data in Google Drive. This this Collaboratory or the Google Colab, it will directly take it from there also. It can read from there. You can upload some data. You can take the data from GitHub as well. If I say new notebook here, it will create one new notebook for me. If you see it here, new notebook on the bottom right, the button was there, new notebook. So if you see it here, it has created the same environment which was available in the local for me. If you see it here, I can again do the coding directly here also. Let us say the same thing. Print, let us say, print machine learning, MACHI, machine learning is fun via Python. I hope all you may be agreeing to it now. Okay, Python. Okay, press enter. So it will just print that method for you. It is connecting over here. You can just see your internet, that live internet connection is required for that. If it is not there, it won't do anything for it. So initializing, it will connect it, and once it is connected, some issues are always there. Machine learning is fun via Python. So we will use this collab only. Now if you see it here, I import, there is now NumPy, already it is installed there. It consists of many of the machine learning algorithms they are inbuilt into it. If I say I want to numpy into my program, import numpy, press enter. So your numpy has come into your program now. Now you can call any functions of the numpy. I want to create one array of numpy. Directly you can create it here. Let us say x equal to numpy dot array. Numpy dot array. It will give you the help also here. That array you want to create of, let us say, 10 numbers. So this method is there directly here. So if you say Z, it will shift enter. It has created those Z number 10 numbers for you also, but it is not visible over here. Z, you can call those numbers 0, or let us say third number I want. So it will say the third number is, oh sorry, yeah, it is some error it is giving. Now one example I will take, some other example, that is I want to create, let us say 100 numbers between 10 and 20. One example I am taking, random numbers we are trying to generate. So it has a very nice method for it, numpy dot linspac linspace. Okay, now here I am saying bit from 10 comma 20. I want to generate 100 numbers between them. Whether you can generate 100, yes, these numbers can be generated directly. You need not to write some code for it. You will see these numbers are generated. Now Z contains these all numbers. If you say the minimum number is 10 and the maximum number is 20, but in between I have hundreds of numbers, 10.1, 10.2, some it uses some mathematics behind it to generate these numbers. So all that is hidden from you because my focus is on these 100 numbers, not on the back end of it, not on the mathematics of it. So I can directly use such methods there. Okay. Now similarly, if you want equally spaced number, then we have another method for it. I will not go into much detail because this is not a Python class. We can talk sometime else about these in detail about these small methods. But let us go further to it. Now, if you see it here, we have already seen these are the two methods. Very quickly, I have done it here. If you further, if you can just see, you can refer the offline sessions also. This is Anaconda Jupyter Notebook and Google Colab. These both are required. These are the two options which are required for writing your Python code for machine learning or any other application it can be. Okay. Similarly, let us now take one live example. We want to do the least square, the linear regression, which is again very important. This you will learn in your coming sessions also, linear regression. I am not going to cover into the details of the linear regression because I think next Anil sir will be taking the detail of these particular regression techniques also. So one of there are linear regression, non-linear regression. So linear regression I have taken it. What is that? If you talk it, regression is used when you try to find out the relationship between the variables. Okay, there are two variables, like I have a temperature, I have the humidity, or I have the yield also I have it. Whether these two combined have something in relation to that yield, or among themselves also do they have any relationship. So it is used for these kinds of things to find out the relationship between the variables. In machine learning and the statistical modeling, that relationship is used to predict the outcome of the future event. वो same whatever relationship you have established over here using regression, that is used to predict the outcome of the future event. Linear regression uses the relationship between the data points to draw the straight line. Now, if we talk about the linear regression, it uses the relationship between the data points to draw a straight line through all of them. So a straight line, it is for the linear regression, but my the distribution of data may not be linear. So I have non-linear regressions also. If we talk about the linear, then it should be the data, the straight line should pass from all the data points. Like this, one example, if you see, these are my data points, okay? And this is my model. This is the regression line which we have plotted over here. Now, this can be used for predicting the future values of these data points. Okay, this can be used. We will see one example of it. Least square estimation. So how to do this one actually? Let us go to the basics also. Machine learning, linear regression. How to do this one? There is one method called least square estimation. Okay, a common problem in the experiment work is to obtain a mathematical relationship y equal to fx between two variables x and y. Only two variables I am talking. by fitting a curve to obtain the points in the plane corresponding to various experimentally determined values, say x and y. Let us say I have these values are known to me. Now I want to fit a curve between these two values using these observations. How to do that one? Now, one of the basic theory or the simplest one, by the pattern of point, one can decide on the general form of the curve. You plot them, and from the pattern of the point, you decide what is that. It can be a straight line. It can be a quadratic polynomial. It can be a cubic polynomial. Okay. For example, quickly I will take it here. Now let us take, suppose you want to fit a straight line. Y equal to a plus bx to the experimentally determined points. These are my points which are determined experimentally or which are obtained from the ground. I want to fit one line to it like this. Okay. Now why I am fitting this line? Because I have plotted this on a graph and was seeing they are into a linear relationship. They are following a straight line. So that's why I am saying I want to fit a line to it. So that you have to, because in machine learning also, first of all you have to plot those lines and then you have to see visually what kind of relationship they are exhibiting among themselves. Okay, it can be a linear, it can be a non-linear. So here I am finding it is a linear relationship. So if these points are on the straight line, the following equalities hold for this. So what it will be true? Y1 equal to a plus bx1. So I will put all these values here first. X1, Y1, I will put it here. Then I will create second equation from it, third equation from it. There are many equations from it. Although I have only two variables, a and b, that need to be determined, but I have n number of observations. So that's why the least square fit means if they will go through the line, but it should the minimum error with the minimum error. If it is going, the line is there. If you see it here in this particular line, so I want to minimize this error. Okay, which is that line in which the error from all this point is minimum. Okay, that is the least square error estimation. So error is minimized by this method, and this particular line is. I can draw line like this also. I can draw some other line also, like I can have a line like this also. I can have line like this also. I can have n number of lines, but which is the best line? That need to be determined. Okay, that so that for that only we require drawing tool. I will just clear from here. It is all drawings here. So we have seen it here. Now we can write the equations like these equations in the matrix form, which you might have learned. Y1, Y2, Yn, 1, 1, 1, X1, X2, Xn, A and B. The same thing, A and B are my two variables that need to be determined. So I can write it in the matrix form also like this. Now more compactly, Y equal to M and V. This is always called the M is the slope, and sometimes we have also the intercept also with it. Okay, M and V, and then where Y equal to this and M equal to this. If you see it here, I have only one variable X1, X2 and X1. So what I have done, I have the first column I have taken as 1 and the second one replaced by the values of the variable, independent variable over here. Okay, if I have quadratic, then I will take X1, X2, Xn, and then one more column I will add, that is X1 square, X2 square and Xn square, like that. So the same method can be utilized for it. Now least square of fitting, we have a very proven formula in the mathematics. Okay, that is V equal to M of transpose M inverse M of transpose Y. Okay, by this I can calculate those A and B values. V, this V value, this Y, using the matrix processes or the methods from the matrices. This formula has been derived. Okay, transpose, then into M, matrix multiplication, then find the inverse of it, M of transpose, and then Y. Now writing a code for this is a huge task. How can I do it this one? So these libraries, they help you out over here. You need not to do all these calculations. They will directly do for it. Okay. So if you see it here, now this is the, suppose these are the points. I have Y, these are Y point means 1, 3, 4 and 4. And your M will be, first column I will write 1, 1, 1. Second column I will write 0, 1, 2 and 3. These are my X coordinates. Okay. Now if I use this formula, this mathematical formula over here, I will get these values as 1.5 and 1. So my equation is Y equal to 1.5 plus X. If you see such of calculation, we can write in 2 lines of code in Python. If you see it here, this is the code for it. Import numpy. This is your matrix 0, 1 and 3 X values. This is your Y values 1, 3, 4 and 4. M matrix 2 it was having. The first column is 1, 1, 1. Second is the Y value 0, 1, 2 and 3. And if you see it here, the transpose if it numpy you have already imported, if you will say m dot t, it will calculate the transpose of it. M dot I, it will calculate the inverse of the matrix. So simple methods are there. Okay, m into t multiply. Now if it is a matrix, then it will do the metric multiplication, not the simple multiplication. Okay, it will perform the metric multiplication over here, and it will find the inverse also here just by this dot notation. Otherwise, inverse nikalna hi, finding out the inverse of a matrix itself is a big task. Okay, you have to write a big code for it. But here, just by putting that I, you will get it. Transpose, so it's simple. You will replace columns by columns by rows and rows by columns. You get it. But here you can get it by this simple T, and you get this plots also. And if you plot it, it goes like this. Plotting is also very simple. From PyLab, import a star. I will share this code also with you so that you can try out of your own. Plot X, Y, R, red dots. R, O. I am writing. If you see how simple it is in Python here. R means red, O means dot. Okay, so R and O, and it is writing it like this way also. Similarly, now what I am doing here, X equal to A range, -1 to 5. I am creating some values from -1 to 5. These are the values. -1, 0, 1, 2, 3, and 4. These values are created. Some X values, now new values. Y equal to 1.5 dot X. So model we have created. This is our model, 1.5 plus X. We have to add this 1.5 over here, and other parameter was 1. 1.5 and 1. Okay, A and B. Your A is this, A plus B. B is 1, so B into X. This is your model basically. Okay, so plot X, Y, comma B. So its line has plotted over here. So it becomes so simple in Python now. The same for the quadratic also. Now, if you see it, I am not going to a detail of it. If you see it here in the quadratic equation also, we have what we have done. First is this, second is this, the third one is your t square. T1, 2 square, T3, X, matlab X1, X1, X2, X3, X4, X5, X1 square, X2 square, because your quadratic equation is like this only, A0, A1, and A2. Now here you have to find out A1, A0, A1, and A2. Okay, these are the values which you need to find out. So similarly, the same concept, the same formula you apply over here, and you will get these values also. If you plot it, you will get a quadratic. Now if you see it here, how exactly it is fitting here. This is your model now. This model has created. Okay. So if you see there, this we were writing using the model, this one. This was our formula behind the model. Now I say I cannot remember this kind of thing for a long. I only remember least square, or I remember linear regression only. So that is also available. If you see it here, multiple regression also it can be used. The same trick can be used for that. And now this example, if you see it here. Now here, I am not writing those mathematical formula. I am directly writing linear regression. From where it has come? From sklearn.linear model. Suppose, first of all, I will import numpy as np. Okay, you import it, numpy. From, this is another method of importing the library. Now I told you scikit-learn, that was another library. So sklearn, the same, we can import that scikit-learn into your program like this. From sklearn.linear_model, import linear regression. There are many more models here, many methods are there. One I have taken as linear regression. If you see it here now, I am creating one X variable, some sample, np.array 1, 1, 1, 2, 2, 2, 2, 3, some X values are there. Okay. Now these values are, let us try to understand it here in your Google Colab. Okay. This was your code over there. Now let us try to take our code one by one from here. Instead of typing it fully, it will reduce some time for me. I will just copy it over here. Okay, so you have the first line. First of all, you have to import numpy as np. Np is what is? Np is an alias for it, because here, if you see it here, I am writing here again and again numpy. Okay, so numpy, so I can write np also, shortcut for it. So if I write it here, numpy as np. So now I can use this np also. Instead of this numpy, I can use numpy. So it will create those values for me. Now the second, the code, the line of code. Now let us create some X variable also. Let us say I will just copy it from here and just paste it here. It is not pasting also over here. Let us say X equal to capital X. I will take capital X equal to np.array, and then I will have this thing. This some syntax is required, need to remember. here. Now here I can write here what are those values I was checking. np.array11. Okay, I have how much is 1 2 3 4 dimension. Okay, so I will have it here like this. One, this is the first element, and then inside this I will have first element, comma, second element, comma, third element. Okay, now the first element is your, if you see it here, this is the first element, 1 comma 2. The same I will take so that we can match it with it. 1 comma 1, 1 comma 2, 2 comma 3, 2 comma 3. Okay, 1 comma 1, 1 comma 2, 1 comma 1 first. The first value is 1 comma 1. Then I have 1 comma 2, and then I have, this is 2 comma 3 maybe. It can be anything. 2 comma 2, 2 comma 2. Then I have one more value, that is one more we have 1 comma 3. Okay, so this is your create 1 comma 3. If you see it here like this. Okay, so your code is here. Now it shows help also over you. You can just press escape to get it away with it. Now if you see it here, numpy, I am creating one array. Let us see what is this array. So if you see, the array is created. Now I will say capital X, press enter. So it has created this array for me. 1 1 1 2 2 2 and 1 3. Now what are these arrays? You can consider them as one variable, and this is another parameter. The same thing for yield, crop yield, I require temperature and humidity. These are the my two parameters. So you can say this is my temperature, this is my humidity. I require the third parameter also, that is yield. Yield or historical yield data need to be required. So for that we can create some sample here. Although I have some live data also with me. We will see it here, y equal to something I am creating over here. One model I will create. If you see it here, np1, this equation, I want to get this equation out of the model. Okay, but I already know it. Okay, so what we will do, np, I'll just copy it from here, Control C. This I will make you understand also here. It is not copying here. So okay, np dot dot product. Okay, because it is not a matrix, but I want the metric multiplication, so I will do np dot, then this dot will use the metric multiplication for you. Now next I will say what I want, x. First the comma, I wanted this equation basically. If you see it here, 2, this is 2 and 1 plus 3 also there. Okay, so I will say it here like this. One is x comma multiplication, x comma np dot, it is again I will take one another np dot array, and then array is your 1 comma 2. So this one I will take some small example. I am taking 1 comma 2 and then plus 3. I would say. I will just explain you also over here. If you see it here, this is this we want to create it, np dot comma np dot array 1 comma 2, then the remaining part. Okay, this is only one element I am taking over. This is your if you see it here, x is your main value. These are the two x values, and then np dot array 1 comma 2. I want to multiply the first one by 1 and the second one by 2. So it will create it. Dot. It will multiply these things. Dot I have written here. Na, x. X is one metric array basically, and I want to do the metric multiplication out of it. 1 I want to multiply with 1, and 2 I want to multiply with this 2 only. So for that I simple multiplication basically. So 1 is x1 and 2x2. If you see it here, my equation is 2x1. x0 plus 2x1. So this is your x0, this is your x1, okay, and plus 3 also. I want it separately here. This is one y values we have created, and you see what are those y values. Print y. So if you see here, these your values are, these your x values, and these are your some sample values I am creating basically. Okay, this is your x0, x1, and these are the y values, the dependent, the predicted. Not the predicted, but the some y values. Now we want to find the relationship between x and y using some mathematical model or using some machine learning model. So now these, I have this data set with me, x. I have the data set with me, y. Let us find out the relationship between them. So that is also very simple over here. If you see here, model equal, I want to develop the model now, model, model equal to, I will say model equal anything, my model, I can say model underscore x, some, or model 01, some model you have created, model 01 equal to linear, linear REGRESS, linear regression. Okay, one model you have created, model 1, by the name called model 1, linear regression. So press enter, so your model is created. Some linear regression is not defined here, linear regression, some linear SSION. Okay, linear regression, I have imported that scikit-learn also here. No, we have not imported. Now it is showing that linear regression is not defined. Why it is not defined? Because we have not imported the scikit library over here, which was like this, from scikit-learn.linear model. So I will, let us try to from SK, the exact name you have to remember here, sklearn, dot here, then exactly we will take it here, linear model dot linear, LIN, linear model, tab you press, so it will go further also, linear model, and then import from here, IMPORT, import linear regression, linear REGRESSIM, linear regression. So that way we have to do it like this way. Okay, we are importing this linear regression model. Once this model is imported, if you see it is imported now. Now let us create that model. Model underscore 01 equal to LINER, linear regression. Okay, so one model I am creating. So this model is created. Now what do you mean by model creation? So it has created the framework of it. Now I want to fit this data set into this model. This is the X data set and this is your predicted data set, Y data set. So let us put it over here. So I will say model underscore 01 dot fit. The same thing will be used across your all machine learning. You have to fit something over it. Fit here X, comma, Y. Simply you can do it like this. If you see it here, there are many parameters for it here. Array, or it can have fit X, comma, Y, sample width you can give, and there are some other weights you can assign. You can have or save, all those things, all those values are optional. So you can have only these two values required. First of all, I require only fitting the variable between X and Y. So if you press enter, your model is created now. Okay, this model 01 is created. Now it can be used to predict any value. Let us try to see it. Equations I am not seeing here. Okay, now if you want to see those values also, model underscore 01 dot coefficient, what coefficient it has created. Press enter. So you see 1 and 2 coefficient it has created. The same thing it has created because we have taken our values are the same thing as we have taken here. This is 1 and 2. These two coefficient it has created. Now let us try to see the values here exact. If 3 is also there, so that can intercept is there actually. Model underscore 01 dot int. What is the intercept it has calculated model? It has taken it 3 only. Okay. So now let us try to predict something. Okay. So how to do it? model underscore 01 dot predict. Okay. What do you want to predict? Now this, if you see it here, you have your values like this. Your X values are 1, 1, 1, 2, 1, 2, 2, 1, 3. And correspondingly Y values are 6, 8, 9 and 10. Means your 1, 1 means 6, 1, 2 means 8, 2, 2 means 9, 1, 3 means 10. These are their outputs basically. Now I want it, let us say for 4, 3. Let us say predict. Now here I will give the same value also over here, predicting its values. Okay, so that you have to give it little bit better way because it is an array. So you have to give it here np.array. Okay, np.array, and then here I will have the values to it. Let us say 2, 3. Okay, you can press it here escape, and then you can give it like this. Actually, first element only. This way we have to give it here. Press enter, so it will give the value here. I think one bracket extra I have put it over here. So let us delete it from there. Let us see now. Okay, parsing. Okay, what is the error now here? np.array. Exactly, I will take it from here. np.array. Brackets are there. One more bracket is required for one bracket is missing over here. Okay, so your 11 is the value. So for 2,3, 2,3 is not here. So I have the value for it is 11. Okay, now let us check with this only. Testing kar lete hain. Let us do that some testing. 1,3 ke liye I have the value 10. But this model is predicting for me now. Let us say 1,3. 1,3. It is predicting 10. Exactly 10 only it has predicted. Because we have using all the values for the training data set. That's why it is predicting it like this. But we have to divide our data set into training and testing so that model can be validated nicely. So this is one small example. Linear regression, we have done it, fit, and then we have tested it also there. For 1 and 3, it is giving 100% accuracy. Your model is perfectly all right. But it does not happen in real time. This model will do something else. So some bias may be there, some errors may be there. So that need to be calculated. So this was one example for linear regression. Now let us take another example, crop yield estimation. So for crop yield estimation, I have some data set. Let us see what is that data set. I will show you the data set also. Crop yield Excel file I am having. So I will increase the size of this font over here. If you see it here, I think it is visible to you. Now, if you see it here, this is the district over here. Then here I am having mean temperature is there, mean relative humidity I am having. Then mean pressure is also there, mean, what is that, wind speed is there. Then we have mean wind direction is there, mean rainfall is there. So this is surface net solar radiation is there, and I have evaporation, NDVI, crop area, production, and then yield. So many parameters are there here. If you see it here, from district here, this is one parameter to now x1 and x2. We have not x1 and x2. We have multiple here. x0, x1, x2, x3, x4. Many I am having. The code we have seen it here earlier. We have only two, x1 and x2. But now in this example, I have many, and I have only one output, that is this yield. So historical data is with me. Let us say what is the historical data. It is from 2001 to 2014. I have some parameters values. I have the yield also with me. Now I want the yield for 2015. What will be the yield? So first of all, I will create the model out of it. Once the model is created, then I can divide this. First of all, what I can do, you can divide this data set into two parts, training and testing. So you train it, create the model, and then test it with the testing data. It is whether it is showing, because for the training, so it will always show perfect only. You give these values, the values will be same only. But you have to divide this into training and testing, so they will test your models also. So once it is tested, then you can apply it for the new data also. For 2015, then you can apply for it. So we have created, this is your data set. Okay. Now let us go into the code. I am not going to execute it, but I will just show you over here. If you see it here, import pandas. So here we have used one pandas library over here. From sklearn, import linear model. These linear models I have the same thing. We have done from there like that. Similar over here. DF. This is data frame, one variable I am creating. Now I have kept that data in my Google Drive also. You can directly upload your data in the Google Drive. If you see it here in the collab, I have uploaded that data here. If you see it here, it will show you the options here. This is option one folder is created over here. Click it is, and then sample data you can upload here. If you see it here, there are many default options are visible to you. But I wanted some data. I want the drive over here. Okay. So first you have to mount the drive at this place. So how to do that thing? That is also very simple. You can upload your data at this place. Again, I will click it to this place. Upload here. Directly from your drive, you can upload to this place. Suppose I have the data over here. Kingston, somewhere I have made the lecture here and an RMS here, or some folder, see learning, then this is the Excel file. Okay, click it here, upload it. So it will upload your data over here. Crop yield data. Okay, now you see it here, it will come somewhere like this. Right click, copy path, and that path you paste it over here. So if I say I am using the library called pandas.read_Excel. Okay, this pandas underscore read Excel. I hope this is visible too. df is equal to pandas and dot read Excel, and this is the path I have copied over there. Then I drop NA. You see some of the, there may be some NA values also, no data also. There may be some no data also. So that can be, if you, I was telling you earlier also, dropping of that can also be done very easily with this pandas. So df dot drop NA. NA means no data. Any, how equal to any, how you have to want to, anything. Whichever is the blank, you download, upload, you can drop it over there. Now df dot drop, some columns I don't require, district I don't require, year, from the data frame, same. Year, crop, production, tons. Production I don't require, I only require the yield. So some of the fields I have removed. You have to see the data set also. That was the raw data. Now I am cleaning the data. df, I am only having, I have removed these columns from there. Then y, I am creating one new variable, the estimation, the one in which I have to do the estimation. Y equal to df dot pop yield. Yield also I have. So I want to pop. Pop means take it out from there. df is your data frame. From there, take these yield value into y variable. So now I x equal to df dot values. Pop means it will remove it from there temporarily from the df. Now df does not have yield. It does not have district, year, crop, and production values are not available in that df variable now. Okay. Now x equal to df dot values. What it will do? It will remove the header. Only the values will remain. Okay. So we have y have the yield values and x have the remaining parameters values in x variable. Now one small example we have to, one coding we have to do. There is some error it was throwing to me. Y equal to, you have to create it into a numpy array. Okay. Y, it has popped it, so it has created one series. But I want not a series, but I wanted a column basically. So if I say y dot to numpy, it will create it into a numpy array. Y will be converted to a numpy array. Then a small reshaping is required. That is it is a one dimensional, but we require it like this. The reshape -1, 1. This we have done so that it becomes similar to your x data values. Okay, it should have one column and one row. Okay, one column and one row it will create for this one. Y equal to reshape -1, 1. Now if you see there model yield, I am creating the model yield. Linear model dot linear regression, because I have not imported from sklearn import linear regression. So that's why I am using linear model dot linear regression. Normalize also we can do true, and then model underscore yield dot fit. Once model is created, the same thing, the fit, we will do it here, dot fit x comma y. This is your x values, these are your y yield values. Then you can predict out also. If you see there, model underscore yield dot predict x0 reshape 1, -1, it will produce those values for you. Predict y regression, predict x, full all x values I want to predict now. Now then we can check it, what the model has predicted and what are the actual values. So this is here I have not divided the data into your train and test. Now if you see here the other code, we can do the same code only. This code I will share with you also so that you can try upon. You try to use this code and try to learn it also. If you see there, one line is required, x train, x test, y train, y test, train underscore test underscore split, from where it has come. If you see it here, from sklearn dot model underscore selection, import train underscore test underscore split, from there it has come. This is a direct module available to you over there. If you see it here, this, now these are the 4 variables. Train, now the beauty of Python, if you see it here, I have created 4 variables, x train, x test, y train and y test, all in same line separated by comma. Directly I can do it. These are the 4 variables created in one line only. And what it will do, this method will generate 4 values, 4 types of values, or 4 arrays we can say. Those arrays will go respectively into train, into test, into y train, and then into y test also. Now if you see here, I am giving size equal to 0.33, it means 33%, around 30%. So 30 values will be your testing and 70% values will be for your training. Random state 42. Each time I run this program, it should give me the same random values, same training and testing data. That's why this random state is given. Any number you can write it over here. So what it will do, it will create the same training and testing data each time you run this program. Otherwise, If you give it nothing false, every time it will create new training and new data set, because it is not like it is creating from first to 70. It will randomly pick up from their 70 values. Okay, and it will randomly pick up some values which will be taken as a test. Train and test, they are randomly chosen 70 values from 100 and randomly chosen 30 values from the 100. It is not a sequential. Okay, so these train and test, and then you give this train values to your model. If you say model x train comma y train, training is given to it, then you predict it. Y predict equal to, this is the predicted value. Now if you see it here, I have plotted this predicted values and the original values also, because y predicted, how I will get it? This model is created. I will say model underscore yield dot predict x test, your test values. Tests are separate now. So it will predict your y values for m. Now for this x test, I have y test also. Y tests are already there, values are there. So now let us try to plot it. Y predicted and y tested. So these are plotted. If you see it, it is not giving a very perfect relationship. Linear relationship is not there. Although it is following some trend over here, but the relationship is not very much linear. Some values are going on here and there. We can plot one line also on top of it to see whether how good our model is into this picture. So this was all about the small glimpse of this Python I have given to you, in wherein you can understand this machine learning also. Now the same program you can make more and more complex. Your complex problems can also be implemented into it. If you see, some small line codes are there. Okay, one line code only, but they all are sequential. No very high-fi programming or the very complex programming need not to be developed for this kind of thing. Only thing, your concepts should be clear for you. Okay, once the concepts are clear and you are aware of different kinds of machine learning algorithms, what are the problems you are going to solve out of it, you can sequentially write your code and you can get the desired results through this machine learning and or the deep learning algorithm. So I hope I have given you a small glimpse of this Python programming, and you might have gained something out of it. If not, then I will share this slide also with you. It contains these codes also. Try to execute this code. These all are the running code. Okay, although this data is, I will try to see if I can share the data with you. Then you can try it out yourself and see how good you can get into this machine learning and deep learning. So with this, this is another one clustering example I was trying to explain, but right now I will just skip it. I will just leave this one as such. Although if you see it here, it is also very simple. K-means, like linear regression. One array I have created over here. Now I want to do the clustering. K-mean I want to do. What you have to do? Just write K-means. How many clusters you want? 2. Random state, start from the 0 only. Okay. And then you can fit this X value into your K-mean. Model I have created, and then fit it directly also. I can fit it. I can write separately also. Then K-means underscore labels. It will produce the label, predict. This value will predict it. Cluster centers, it will create your cluster centers. So it becomes very simple in Python, basically. So with this, I close